Okay, we are back. This is Techmath2. We're looking at Chapter 11. We are back into the Red Book. Yay, Red Book. We'll be using the Red Book for the remainder of the semester now. So we're taking a look at Chapter 11. That is on page 474 in the Red Book. And we're looking at number 2. We're working with sine waves. So remember how sine waves work? We did it a little bit with right triangle trig. We're going to examine sine waves a little more. And so now they threw a number in front. What that does is it increases the amplitude. So a normal sine wave goes up as high as 1 and down as low as -1. But if you throw like a number in front of it like this, y equals 2 sine 90 degrees, what it does is it changes the amplitude. So now it goes up as high as 2 and down as low as -2. And so they wanted this 2 sine 90. Now you don't need the picture of the sine wave for this problem. You can just click it into your calculator, make sure you're in degrees, go mode and hit degrees. And then, so y equals 2 sine 90, that's going to be 2. And then they want to know 2 sine 270. So you could just tick that in, 2, and then hit the sign, and then hit 270, and then hit enter, and that'll click out a -2. That happened right here. And then they ask for 2 sine -60. Now that one you probably don't know off the top of your head, like off of your picture. We just know it's somewhere around here. You know, -90 is here. So -60 is somewhere in there. So you pop that in, 2 sine -60. It would be the same. You know, there's a little bit of what do you call it? Symmetry. If we added 360, it would be the same as right there, 300 degrees. All right, but you pop that in, and your calculator kicks out -1.7, and it goes on more than that. We'll just go to hundredths place. It said 2 decimal places if necessary, so -1.73. All right, that is number 2 on page 475. So let's take a look at number 7 on the 477. So still in 11.1. Number 7, they want me to find y equals 4 sine theta. In the following equations, if the following equations are graphed, what would the amplitude be for each one? Okay, and so this, it turns out to be a pretty easy question. Theta, C is 300 sine theta. And D is y equals 7.41 sine theta. What was going on in my brain there? Okay, so amplitude is equal to, amplitude is equal to, amplitude is equal to, and amplitude is equal to. So just like here, where there was a 2 in front of it, and then basically multiplied, you know, it took the amplitude up to 2 and down to -2. If there's a 4, the amplitude would be 4. So if this were the picture for this problem, this would not be a 2, this would be a 4. And that would be a 4. You know, it would go all the way up to 4 and all the way down to -4. 10, it would go all the way up to 10, all the way down to -10. So the amplitude is 10. 300, that would be into the rafters and down to the floor. And 7.41, it would just be 7.41. So, I mean, to do the problem, it's super easy. The number in front of the word sine or cosine is its amplitude, the absolute value of it, by the way. Even if I had -4 here, the amplitude would still just be 4, not -4. Amplitude is the distance that the sine wave deviates from 0. So how far does it go up? How far does it go down? So if I said -4, that would just open it down, but it would go down to 4 and all the way up to +4. So the amplitude would still be 4. So whether that is a positive number or a negative number, the amplitude is basically the absolute value of the number in front of sine or cosine. Both of those have amplitudes. All right? Okay, let's take a look at 11.2, non-fundamental sine waves. So 11.2, we're going to be, I think, shifting him a little bit. And this does get a little tricky, unless you're visual. If you're a real visual person, these will be easy peasy. I'm not very visual, so I have to really put the thinking cap on to do this. All right, so let's see. For 11, they want us to find the sine. Y is equal to the sine of 180 degrees minus 60 degrees, which is really just the sine of 120 degrees. And we just pop that into our calculator. And so that ends up to be rounded 0.87. All right, what about negative 210 minus 270? Minus 60 rather, is, okay, so they're basically saying, look, no matter what you have here, so this ends up just being plug and chug, sine theta minus 60 degrees. So this is the equation that they're giving you. So then they give you theta, you put it in, 180 minus 60 is 120. So you're actually finding the sine of 120, not the sine of 180. What that essentially does is minus 60 shifts the sine curve. And if you look at what it ends up being, you know, instead of that 180 where it's supposed to be, it's 60 degrees to the left is what's happening here when you subtract 60 from it. Okay? So we're at 120. Same with the part B here. Is, well, what about y equals the sine of negative 270? If theta was negative 270, but then we took 60 more degrees away from it, you'd actually be finding the sine of negative 3, whoops. Oh, I'm sorry, that's negative 210. I didn't read carefully, sorry. Theta was negative 210. Negative 210 minus 60 is negative 270. And so you pop that in and you get 1, just positive 1. And again, if we take a look at the sine curve, what's going on here on that first one, it was, they wanted 180 was theta, but then it was minus 60 degrees in the equation. So we actually walked it back 60 degrees and found the sine of 210. That's how we got the 0.87. Then negative 210 was over here, and then they walked it back 60 more degrees to negative 270. And so that was why it was positive 1 if you do that. Right? Didn't leave enough room to do that part. All right. So that's 11. So what would plus 30 on the inside do to it then? Basically, let's take a look. So these, you can still use your calculator basically to do these problems. But it's good if you can kind of get a visual of what's going on. So 12, they have y equals 4 times the sine of theta plus 30, inside the parentheses there, degrees. So no matter where we give him theta, it's going to shift it 30 degrees to the right, 30 degrees down the sine curve. And so let's take a look at what happens. And they said if theta is equal to 300 degrees, what do we end up with? And if theta is equal to negative 150, what do we end up with? Well, 300 is going to become this, y equals 4 sine of 330. And you pop that in your calculator, and it'll kick out a negative 2 for you. And negative 150 plus 30, that becomes negative 120 for sine negative 120. Now there's a 4, so the amplitude has changed also. So that's why you throw that into your calculator, and we'll have to round. It says 2 decimal places again, so negative 3.4, is that a 6? Yep, negative 3.46. Okay. So we're just kind of using our calculator for those. Let's take a look at 15 and 16 and 17, because it gets a little more. Oof. All right, so I'm going to erase the board here. So again, we are in the red book, 11.2. We're on page 480. Take a look at number 15. And they have the sine curve drawn out for us, and it's going all the way up, it looks like, to 40 and down to negative 40. Sorry, I'm not a really good drawer, as you can see. Okay, so somewhere along those, and up as high as 40, and it looks like it's shifted. Why is the sine wave a non-fundamental sine wave? So that's the first question. Why is this non-fundamental? And that is because it is out of phase. It's shifted to the left or to the right, and so it doesn't start at 0 and end at 360 and then start replicating itself from there. It isn't cycling from 0 to 360. So it's considered non-fundamental when we shift it to the right or to the left. And so that is a non-fundamental sine wave. And we'll just say because the cycle is not from 0 to 360. That's the normal period of this periodic function. The only basic cycle on the graph is from what to what. And so you're going to have to look at your book there, because my picture is awful. It looks like it starts halfway between negative, like they have negative 90 here, and this looks like the halfway point. So we're kind of guesstimating, because they didn't give exact, but like negative 45 degrees to, and then it goes 270 to 360. So to 315, if you add 360 to that, that's happening like right here is to 315 degrees. So it's still a 360 degree cycle, but it doesn't start at 0 and end at 360 and then start again. It starts at negative 45 and ends at 315. There are positive peaks where and where? Well, at theta equals, it looks like 45 degrees, like right here again. Again, you're going to have to use the picture in the book, because mine is not good enough to discern that's halfway between 0 and 90. So that's 45 degrees is peak. And also, let's see if we can figure it out from there. Well, if we just add 360 to it, that would be 405. Because, right, it's going to cycle one period. So 360 degree period, and so 405 degrees. So you figured that out from the picture, but I don't think you could, unless you're really good, that you could just look at that and go, oh yeah, that's 405. All right, and the amplitude is that one. You could tell, again, from their picture, it's up as high as 40 and down as low as negative 40, and that is the amplitude. So the amplitude is 40. You just say 40. All right. Okay, let's look at 16 and then also 17. So I want to look at 16 and 17 still on the same page. So 16 is a little easier. 3 sine B 500 minus 45 degrees. is C. Y equals 7.5 sine theta plus 90. And D y equals 83.1 sine minus 60 degrees. Okay, so they said if the following equations were graphed, what would the amplitude be for the non-fundamental? Okay, so they just want amplitude. So again, you don't really have to focus on this. This is going to pick up the whole graph and move it. It'll actually move it to the left and drop it down because plus 30, you know, everything that would have happened, it moves it opposite of what you would think. But they're not interested in that. They're not interested in the shift right or left. They're just interested in the amplitude. So these are actually pretty easy. Amplitude is 3. Amplitude is 500. Amplitude is 7.5. And amplitude is 83.1. And again, let me remind you, whether that is a positive or a negative on that first number, all of these ended up being positive again. The amplitude is always, always positive. It's like the absolute value of. It's the distance from the x-axis. So, all right, and then let's look at 17. Which of the following equations have graphs that are non-fundamental? So A would be fundamental because that's just 60. It's just got an amplitude of 60. B would be non-fundamental because they're shifting it. So sine of theta minus 50 in the parentheses and then degrees, that's a shift. That's a shift from left to right. So that's a non-fundamental sine wave. And then C would also be non-fundamental. Because that is y is equal to 14.5 sine of theta plus 15 degrees. And so that is also non-fundamental. A and D would be fundamental. They would just have different amplitudes. So if it has a different amplitude, but it starts at 0, ends at 360, and then starts repeating itself from 360, it's fundamental. If it starts somewhere else, it's non-fundamental.